Let's dive right in. What actually happens when the weather turns against our global food supply?
To really grasp the massive stakes here, we're using India as our main case study.
Get this, a staggering 42.86% of India's workforce relies on agriculture. The human impact? Absolutely astronomical.
Just look at this 50-year data. Temperatures have shown a persistent, totally undeniable upward trajectory.
Meanwhile, overall rainfall looks stable, but that hides dangerous volatility. Rice season rain actually dropped 7%.
This brings us to nonlinear impact. You can kind of think of it as a crop Goldilocks zone.
Crops thrive with optimal heat and rain, but cross that specific threshold, yields just plummet. Like pigeon pea, it loves increased water evaporation right up until a tipping point where yields totally crash.
Let's watch this build. Historically, baseline cereal yields across India back in 1966 looked like this. Then by 1990, the Green Revolution brought huge, undeniable productivity gains across the entire map. And by 2016, massive yields. But honestly, this growth is masking a looming, climate-driven crisis.
Because as temps keep rising, we're now seeing clear winners and losers in the agricultural world. The daily staples we rely on most, like rice and wheat, they're highly vulnerable to the heat.
In fact, without adaptation, rain-fed rice yields could literally collapse by 47% by 2080.
But surprisingly, not everything is doomed. Crops like pearl millet actually show far greater climate resilience.
The catch? Even resilient crops like cotton remain incredibly sensitive to erratic rainfall patterns. Looking ahead to the 2080s, projections are warning of severe temperature spikes up to 3.9 degrees Celsius.
Plus, extreme monsoon rainfall could surge by over 24%, which would just totally disrupt agriculture.
So how do we survive this? Well, this explainer outlines some clear, data-driven adaptation strategies.
We urgently need climate-resilient seeds, water-saving tech, and diversified crops to survive these shifting environmental thresholds.
The Goldilocks zone is definitely shifting. So are we prepared to adapt before that final tipping point?